Hello, everyone, and welcome back to your channel of Math Made Easy. Today, I want to go over integration by substitution and show you different cases. And I prepared few examples here. So the first example, suppose you want to integrate um, natural log of x over x dx. How do we integrate that? You see that what causing the problem is natural log of x, right? Because how do I integrate that? Well, we can integrate it by parts, but I know how to integrate 1 over x or differentiate it, but at the same time, I cannot integrate. I can differentiate natural log of x, but I cannot integrate it. So I can use integration by parts. However, there are basically, I'm going to show you how we do it. And then I want to take like a leap of faith and tell you what you can do to simplify these types and start thinking about integration slightly different in a different way. Substitution is easy since I don't know what natural log of x. That's the problem. So I'm going to say let u equals natural log of x. And then take the derivative of both sides, meaning I'm going to take, I say, then du, the change in u, would be 1 over x dx. Okay? Now, do you see that this thing is the natural, can be written as the natural log of x times dx over x or times 1 over x dx? So this whole thing is du. And that thing is u. So now you are integrating u du, which is u square over 2 plus a constant. And then you go back and say, oh, this is u. U was natural log of x. So you go back and say natural log of x quantity square over 2 or 1/2 plus a constant. Okay? So that's basically an easy one, right? But I also can think of it slightly different by saying the following. Here is my integral. I'm going to rewrite it like that. But I recognize that this thing is the derivative of that, right? So I can rewrite it as the integral of natural log of x d natural log of x. What? Yes, that's the derivative. What is the derivative of natural log of x? You say 1 over x times dx. 1 over x times dx. So now I have a function times its derivative. So when I integrate it as if this was x dx. So I get x squared over 2, meaning it's natural log of x squared over 2 plus a constant. And that's basically the substitution itself. That's what we do in a substitution. Now let's take another example that would make it even clearer than that. Okay, so here I'm going to say my function, I want to integrate e to the power of cosine x times sine x dx. If that was e to the x, I know how to integrate that. So if that's causing the trouble, I would say let u equals cosine x. So du would become negative sine of x dx. Well, I have sine x dx here. So I'm going to substitute that with negative du. And cosine x is u, so this is negative e to the u du. Easy, right? So you get negative e to the u plus a constant, or negative e to the cosine of x plus a constant. Also, if I had seen that the derivative of cosine is negative sine, I can rewrite this as negative e to the cosine x times negative sine x dx, and then say, oh, that's the derivative of cosine. So this can be written as negative e to the cosine of x, okay, d cosine of x. So that looks like e to the u du. And again, I could have done it negative e to the cosine of x plus a constant. Okay, so that's uh, how easy you do those types of substitutions. I'm going to go over now definite integrals. So let's take a few more examples just to make sure you get that. Okay, I have an example here that says take the integral from 2 to 5 of 3x squared times the square root of x cubed minus 4 dx. Again, every time I see a square root with a power and the derivative of that is 3x squared, right? Oh, it's out there. So it's much easier now to say, let u be the quantity under the radical right away. Because now du would be 3x squared dx. Notice the derivative of a constant is 0. So I have, in fact, this was an easy problem because I already have 3x squared dx would be replaced by du, right? And this guy is u, so that becomes the square root of u and the integral of that. Here we face a problem. There are two ways to proceed. I can proceed with this as if it were an indefinite integral and then substitute back in x with the limits, or I have another way to do it is to change these limits of integration from the x domain or from the x word into the u word. So the first way I'm going to do it, I'm going to say this is the integral really of u to the 1/2 du, right? The square root of u. So the integral would be to add 1 to the power, so it would be 3/2, and then divide by 3/2, which is multiplied by 2/3. And then say, oh, but u is this guy. So the answer, of course, here we don't have a constant. Well, in this case, I would add a constant, but I don't need it because in the x word, it's a definite integral. So I get 2/3 x cubed minus 4 to the 3/2 evaluated from 2 to 5. That's the first way to do it. Okay, so I get 2/3, and then 5 cubed is 125, minus 4 is 121 to the 3/2, minus 2 cubed is 8, minus 4 is 4 to the 3/2, equals 2/3 times 121 to the 1/2 is 11. 11 cubed is what? 11 cubed? I'm afraid to tell you I get that from Pascal triangle because you're gonna hate me because every time time I have um, a way to do it, I would. So 4, the square root of 4 is 2, 2 cubed is 8. Okay. So 2/3 times 11 cubed minus 2 cubed, right? No, minus, oh yeah, minus 2 cubed. 882. Well, here is 11 cubed. And of course, you get that from the third row of Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? Okay. I just wanted to show you that. So what is the other method? The other method is that after I integrate that and I got 2/3 u to the 3/2, I say, okay, let me change the limits of integration. How? I say when x is 2, this is 2 cubed, which is 8 minus 4 is 4. And when x is 5, this is 5 cubed, 125 minus 4 is 121. So I'm taking the integral from 4 to 121. Notice, we saw these numbers here. So really the answer would be 2/3 times 121 to the 3/2, 121 to the 3/2, minus 4 to the 3/2, minus 4 to the 3/2. So I don't need to go to u and then back to x. I can do it all in the u universe, so to speak. Okay? So you have two ways to do it, really. Let's take one more here. Oops, it's broken. Okay, change it. Let's take another example. I have an example here. In fact, these examples, I'm using them in a book that I'm trying to publish, but I don't know if I will have the time. It's because the book is really spread over, beginner stuff and then intermediate stuff and then advanced stuff. So I can combine all of them in one textbook. So maybe I'll make like notebooks, so to speak, and see if these can help students. Okay, so the integral from 0 to 1 of the square root of 1 minus x squared dx. That's an easy one. And usually when you see a difference of two squares or a sum of two squares or stuff like that, you always, without thinking, your mind should go to trig functions. Why? Why trig? Yes, you got it. Because I know that sine squared plus cosine squared equals 1. So if I consider that to be sine, the x is sine, then sine square, 1 minus sine squared is cosine squared. Under the root, it becomes cosine. Or if I consider that as cosine, then I can get the I can get sine square 1 minus sine square. So I either get sine or cosine. So how do we do that? Well, if you use the only problem is that when you use sine or cosine, let me show it to you in writing. If I say let u equals say sine of theta or sine of x, I'm sorry. Okay? Then what x would be? X would be the inverse sine of u. Right? So I have to do it the other way around. I have to say let x equals sine u, right? Because now when I square that and subtract it, I will get cosine. So you can do it both ways, but it's easier if I say x equals sine, right? Because now dx becomes cosine of u du. Now, if I substitute here, I will get the integral of the square root of 1 minus sine square u times cosine of u du, because that's dx. dx is cosine u du, and the square root of that is the square root of that. So that becomes the integral of the square root of 1 minus cosine square is the square root of cosine square is cosine of u. Cosine of u times cosine of u is cosine square u du. And like I did last time, I can either stay with u, change the limits of integration, or solve this as if it were an indeterminate integral and then go back and substitute in x and then evaluate from 0 to 1. It's up to you. But notice that here I was showing you which way to go, because some people would say, okay, let me use that, and then find that's the inverse, it's too complicated, so you go back and do it this way. Anyway, so here I would say if x is 0, what is u? Well, I know that sine 0 is 0, so u is also 0. What about x is 1? When would x be 1? When sine of pi over 2, so that becomes pi over 2. So I would integrate from 0 to pi over 2 cosine square u du. In order to integrate cosine square, you know that we can divide it into two things, right? I know that cosine square comes in three flavors, so to speak. How do I get cosine square of u? Remember that how we in trig, how we said cosine of 2u can be written in three different ways. Cosine square u minus sine square u. That doesn't help, right? Because I only have cosine square. So if I substitute, I will get cosine 2u plus sine square. It's even more complicated. Or I can get one of these two things. 2 cosine square u minus 1, or 1 minus 2 sine square of u. Well, I already have cosine square u. So if I use that and add 1 to both sides and then divide by 2, the cosine square u becomes 1 plus, or cosine 2u plus 1 over 2. Right? You add 1 to both sides, so you get 1 plus cosine 2u, and then you divide by 2 to get cosine square. So I'm going to rewrite. Notice I didn't change the variable. It's still u, so there is no reason to change anything in the limits of integration. That becomes the integral of 1/2 plus 1/2 cosine 2u. I'm going to show it to you step by step, du. The integral of 1/2 is u over 2, and the integral of cosine is sine 2u divided by 2. So it's 1/4 sine 2u. And everything here is evaluated from pi over 2 to 0. Notice that if u equals 0, sine 2u is sine 0, which is 0, and u over 2 is 0. So I don't care about subtracting. I only going to apply pi over 2. So I get pi over 2, which is pi over 4. And then if sine 2u, u is pi over 2, so 2u is pi, sine pi is 0, so plus 0, so the answer is pi over 4. Okay? Like I said, we could have used what do I have after that? Or like do I have another example? I think I have another example. Okay, yeah, I do have another example. So let's finish the last one. And the last one says integral from -1 to 3 of x minus 5 cubed dx. That's an easy one, right? Again, I can use substitution, which is not needed at all here. If you noticed what we did in the first couple of examples, you would see that, oh my God, I got it. But let's assume I'm new to integration by substitution, and I say, should I expand that as x cubed minus 15x squared plus 5x minus whatever, or 25 and minus 125? No, you don't need that at all. If that is causing the trouble, you say let u, that's the long way, by the way, let u equals x minus 5. Then du becomes dx. Oh, so I got rid of the -5. That should tell you something, but we are going to assume we don't know. So I'm going to take the integral. If u is x minus 5, then this becomes u cubed. U cubed. And du is dx, so u cubed du. The integral of that is 1/4 u to the 4th plus a constant, but this becomes 1/4 x minus 5 to the 4th evaluated from -1 to 3. So it equals 1/4 times. When you substitute with 3, you get -2 to the 4th. And when you substitute with -1, you get -6 to the 4th, right? -2 and -6. Okay, so it's 1/4 times -2 to the 4th is positive 16 minus, notice -6, not negative times negative. No, it's -6 to the 4th, which is 36 squared, which is 1296, right? So you get -1280 over 4, which is -320. Yes, some of you already knew what to do. They would say, well, the derivative of what's inside the parentheses is dx. So can't I write this as the integral of x minus 5 cubed dx minus 5? Yeah, of course, you can add and subtract a constant, and the derivative of that is dx. And if you see that, there is no reason to do any substitution. You would say, well, this is the integral, or this becomes x minus 5 to the 4th over 4, which is this guy. A third method is to say, well, since I did the substitution, why go back to x? Let me find if x is -1, then u is -6. And when x is 3, that is -2. And you would have done it right away. You would say 1/4 times -2 to the 4th minus -6 to the 4th. So it really, theoretically speaking, we had 3 ways to do it. Either go to u and then back to x, or notice that the derivative of what's inside is basically dx, so you can rewrite it as that. Or when I move to u, I change the limits of integration and stay there. And in all cases, you will end up with -320. Okay? Of course, you can always use the calculator to check your answer, just to check, not to answer, because we want you to show your solution and your steps of doing that. I hope this was an easy one and you enjoyed it. If you have any questions or comments, please leave them in the comment section as usual. And thank you very much for watching and hope to see you soon.